Hi, welcome to a video on analytical geometry, coordinate geometry. We're going to be looking at the NSC grade 12 November 2023 paper on this section. So we're going to question 4, and it reads, in the diagram, the circle with center O has the equation x squared plus y squared equal to 20. So there's our circle center O. And remember that if we have 20, that represents r squared. Your radius will be the square root of 20. Now G, they give us, is a point T0. So we know the y value of G is 0. And it is the center of the larger circle, which we can see the big circle. We have a common tangent, and it touches D and F respectively, such that D, so they're giving us the coordinates of D, which is P minus 2. And then we're going to put that down. Let's start with that. So we give us the coordinates of D to be a point P minus 2, which represents your X and Y. And it also tells us that it lies in the fourth quadrant. So we're going to go to 4.1. And 4.1 says, given that dP minus 2 lies on the smaller circle, show that P is equal to 4. So to do that, all we have to do is go to the smaller circle's equation and substitute the point. So we have x squared plus y squared equal to 20. Now we have D. The x value is P. It'll become P squared. The y value is negative 2. Sorry, that jumped a little. Which we're going to put into our equation, and that is equal to 20. So P squared would be, we're going to, minus 2 squared is 4. Take it on the underside, that gives us a negative 4. P squared is 16, and P would be plus minus the root of 16, which is 4, and we're going to choose P. If we look at P, the x value is positive. It's on the positive side of the x axis, and therefore we get P to be 4. We're going to go to the next question. Okay, so the question for 4.2 reads, E is a point 6,2. It's the midpoint of DF. So I'm going to go to E. Let's quickly highlight that line. So we look at line DF, and E is a point 6,2. Let's put the coordinates down. So while we have that, I'm going to quickly go and remind you of D. That now that we have D, we can put the coordinates of D down as well. And remember, D was a point given to be P, which we found is 4 minus 2. And we know that E is a midpoint, which means that ED will be equal to EF. It says determine the coordinates of F. So let's call F to be X, F, Y, F. Okay? So we know that E is the midpoint. So remember, this is the midpoint. And the midpoint formula, if you forgot it, is x of the midpoint will be x1 plus x2 all over 2. So now we have the midpoint, and E is the midpoint. So x of the midpoint is 6. So x1, we'll use xf. And the x value for D is 4. And that's all over 2. So we're going to put 6 over 1. Cross multiply, we're going to get x f plus 4 times 1 is the same thing, and 6 times 2 is 12. So a quick cross multiplication there. And that gives us x for f would actually be 12. We'll take our 4 on that side, becomes a negative 4. That gives us 8. In the same way, we're going to find the y value, yf, would be y2 plus y1 all over 2. So the YF, sorry, not the YF, let me change that. That's the Y of the midpoint. That's the midpoint formula. And the Y of the midpoint, we're looking at point E, is actually 2. Which is equal to Y1. We're going to use YF. Plus Y2. We're going to use the negative 2 for D. So I'm going to change that to a negative 2 all over 2. And once again, we're going to put 2 over 1, cross multiply. We're going to get YF minus 2 is equal to 4. The Y value of F, take your minus 2, becomes a plus 2. It goes on the other side, giving us a 6. And our conclusion is that F would be the point 8, 6. Okay, we're going to go to the next question, which is 4.3. And let me give you some time to read that. Okay, now that you read it, it says determine the equation of the common tangent DF. Now, if we actually look at DF, we actually spoiled for choice here. And the reason why I say that is that we have 3 points. So to find the equation, we need to find M using your gradient formula, which is Y2 minus Y1. So I'm going to use points E and D. I'm going to use my points E and D to find the gradient. And if we use the E value for Y is 2 minus minus 2, which is a plus 2, over the X value for E is 6 minus the Y value for D, sorry, the X value for D is 4. And if we do that, we will get 4 over 2, which is equal to 2. So just to remind you, I'm using the simple gradient formula Y2 minus Y1 over X2 minus X1. So we got the gradient to be 2. And then to find C, we can sub any point we want. And once again, we spoiled for choice. So I'm going to use, the easiest point for me to use here is 6, 2, because both are positive. So the Y value there is 2. The M value, which we just found, is 2. The X value is 6. I'm using point E plus 6. And that gives me 2 times 6 is 12. Take it on the other side. It becomes minus 12. And that gives me C to be negative 10. So my equation would be now 2x minus 10. That is the equation of DF. Okay, so I'm going to erase that. You can keep that answer down. We may need it for later. And we now go to 4.4, which you can start reading on the screen in the bottom. And that question wants us to calculate the value of T. Now remember, T, if we look into the diagram, is we're looking at G to be T0. So you can think about that, how we're going to do that. While you're thinking, okay, there are a few ways we can do it. The quickest way that I'm going to look at to find T. So in the previous question, we found out that the gradient, it jumped a little. We found out that the gradient of DF, that's the tangent, the gradient of the tangent, I'm going to write that down. The gradient of the tangent was actually equal to 2. Now remember that the radius is perpendicular to a tangent. If G is the radius. So we know that the gradient of FG would actually be negative half. And that is because FG is perpendicular to FD, and the reason there is radius perpendicular or tangent perpendicular to radius. Now if we look at F and G, we can use those 2 points to find the gradient and form an equation because we have the gradient equal to minus half. So let's quickly go and find out what is the gradient. I just want to change the color. So we want to know what is the gradient of FG if we have to use the coordinates. If the coordinates is 8, 6 and G's coordinates is T0. So if we do that, that will actually be equal to y2 minus y1. I'm going to start with the G value of 0 minus 8 all over x2 minus 1, x2 minus x1. The G value for x is t and minus 8. So that is the gradient of fg. But looking above, we know it's equal to minus half. So we now have an equation. So we have 0 minus 8, which is negative 8, all over t minus 8, which is actually equal to negative 1 over 2. So to work it out, it's quite simple. We can find an LCD, or we can cross multiply, which is the easy way I'm going to go with. T minus 8 times a positive 1 is t minus 8, and minus 2 times a negative, minus 8 times a negative 2 would be 16, and therefore t would be, take your minus 8 on that side, becomes plus 16 plus 8 is 24. And that is how we find the value of t. But I think I've made a mistake, and I'm quickly going to find my mistake in this question, 4.4, because I'm just looking at the gradient to be minus half. And if your gradient is negative half, then when we cross multiply, we're going to get t minus 8 times 1 is t minus 8. And your minus 8 times your minus 2 is a positive 16. Okay, and I found my error. It's very silly error that I need to correct quickly. And I'm going to go over to the red pen. I hope you found it as well. So initially I said 0 minus fg, y2 minus y1, it's 0, if you look at the diagram, 0 minus 6 and not 8. So that 8 should be changing to 6, and that gives me a 6 there. So when I multiply, that will become a 12, and 12 plus 8 is actually 20. So very simple slip up. Instead of putting 6 there, I put 8. Thank you. Let's move on. Okay, we're going to go to the next question, which is 4.5. The question reads, determine the equation of the larger circle in the form ax squared plus by squared plus cx plus dy plus a plus e. Let's forget about the form. Let's see if we can find the equation of the larger circle. Now, in the previous question, we found G, which is the center of the circle. And the equation of a circle is x minus a all squared plus y minus b all squared is equal to r squared. And remember that the center represents your a and your b. So here we start. We got x minus 20 all squared plus y minus b, which is 0, and then we'll end up with y squared is equal to r squared. Now, we need to find what the value of r is. We have the center. So to find the value of r, we're going to substitute point f, and point f is 8, 6. So the x value for f is 8. We're going to bring it in. 8 minus 20 all squared plus the y value is 6 all squared is equal to r squared. And you can work this out with your calculator, and that will give you 8 minus 20 is minus 12 squared, 144, plus 6 squared is 36. and we're going to put that together, 144 plus 36, and that should give me 180. Okay, we can find the radius by finding the square root, but remember the equation of a circle is x minus a, which is 20. I'm going back to line 1, if you did my line 1, plus y minus b, which we said y minus 0 all squared, will be equal to r squared, and r squared is actually 180. Okay, going on to the last question. Okay, looking at the last question, I just want to erase this. Okay, and the question which we've already read, if you haven't read it, let's quickly remind you. The smaller circle must be translated by k units, so it must be moved by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. So what we know now is that the radius of the small circle, I think I should change the color to illustrate that. The radius of the small circle we have found, it's the square root of 20, and the radius of the larger circle, because we found the equation of the larger circle in the previous one, is actually root 80. And we know that the total distance from O to G is actually 20 units. So there's a small distance that you can see between the circles that it has to move, and to work out that distance so that it will touch the big circle. And if we work that out, it's actually the total distance of 20 would be equal to 20 subtract root 80 subtract root 20. And you can use your calculator for that. Actually, root 180. Sorry, the previous question, it was root 180. Okay. And if we subtract that using our calculators, and your calculator should tell you that k would actually be equal to, using your calculator and subtracting, sorry, I should be putting a bracket on this, okay, for it to touch. So what we're saying is, if we take the 20 units for it to touch, and we subtract the difference of both, we will get it to be able to touch internally. And if you use your calculator and you do the calculation on that, that will give you 11.06. Okay, but also for it, as it's being translated, it will move into the big circle, and to ensure it doesn't go beyond the touching, we would now have to take k and take the total distance of 20 and then add it to the difference of root 180 minus root of 20. And if you use your calculator for that, that will give you k to be equal to 28.94. So you can see the circle, just to remember that what we are doing there, is we're looking at the radius to be root 20. The radius of the big circle is root 180, and the distance from O to G is 20 units. And therefore, if we take 20 and we subtract the difference between both the radiuses, That will give us a touch. And then we can also add it to that so that it doesn't go beyond the point, and make sure that K will be the two values called 11.06 or 28.94. So let's read the question again. The small circle must be translated along the x-axis to touch the larger circle internally. Okay, and calculate the possible values of K.